Dear students, in this lesson I am going to discuss with you the concept of dummy variable and its applications. In this particular lecture I'll try to cover its meaning and its two application. The remaining application will be covered in the next lecture. So first of all, what is dummy variable? So it's basically a qualitative variable which can be assigned value 0 and 1. For example, intelligence is a kind of quality. So if it is present, if somebody is intelligent, so we'll assign 1 to that person. If the intelligence is absent, if somebody is not intelligent, then we will assign 0 value to the variable. There are some other names of this of dummy variables. This is also called binary variable as it assumes either 0 or 1 value. These are also called indicator variables because it indicates the absence or presence of a given quality. Similarly, they are called categorical variables because they can divide the population into two categories, intelligent or unintelligent, for example. And another name is dichotomous variable because of the fact that the objects can be put into two naturally mutually exclusive groups. So male, female, success, failure. So you can divide the any incidents into two categories. For example, suppose there are 10 persons A, B, C, D, E, F, G, H, I and J, where person A, B and F are literate person. Then dummy variable on literacy can be formulated as follows: persons, and then this is dummy variable. Person A is literate, so we'll assign 1 to person A. B is also intelligent, so we'll assign 1 to B. Then all other person except F. F is again a literate person, will assign 1 to F person, and all other values are 0. So in this way you can formulate a dummy variable. Now how can we formulate a regression model with the help of dummy variables? For instance, you all know that consumption function can be of this type, where beta 0 is intercept and beta 1 is the slope of the consumption function. So your consumption depends upon certain conditions, certain variables. So income is one of that variable, and if there are some particular kind of condition, for example there is war in the economy, so war in a country, so in that case your consumption expenditure can vary. So your intercept can vary and your the slope can vary. So you can define your consumption function with the help of dummy variable like it is shown in this consumption function. So we will discuss how in the following section that how intercept and slope of the regression models can be formulated. So now its application. Its first application is associated with change in intercept or and slope. So first of all we'll show how the intercept value change can affect the regression model. Dummy variable can be used to show shift in the regression function. Let us explain on the basis of the following example. Consumption function. So this is your consumption function. C is equal to alpha beta yt plus beta 2d. Now here d is your dummy variable. So now you want to show the change in intercept in alpha. So for that you have not put the d with y. You have put or defined the d without y, without income. So alpha plus beta 1 y, beta 2 d. So how you will define here dummy variable? Dummy variable, it will have value 1 when it is boom period, and it will have value 0 when it is depression period. So there are two cases. Case 1, when it is boom period, then d will be equal to 1. So what will be the value of consumption function? So here d will be equal to 1. So put d is equal to 1. So you will get alpha plus beta 1 yt plus beta 2 plus ut, and ct is equal to alpha plus beta 2. Now this beta 2 will be added to the intercept, since beta 2 is constant and no variable is attached to beta 2. So alpha plus beta 2 will be your new intercept. Earlier intercept was only alpha, and now the intercept is alpha plus beta 2, and there is no change in the slope remaining the same, beta 1. Now if there is depression, then d is equal to 0. So value of d is equal to 0. Now your consumption function is simple, alpha plus beta 1 yt ut. So now your intercept is same, alpha, and in case there is boom, then your intercept is alpha plus beta 2. So now we can also show this in the form of a diagram. So earlier your line was this was your original regression line, ct is equal to alpha plus beta 1 yt, and when there is change in, when there is boom in the economy, now your intercept is alpha plus beta 2. So there is a shift in the consumption function. There is no change in the slope is same, both lines are parallel, and beta 1 is equal to beta 1, but there is change in the intercept. Earlier intercept was alpha, and now intercept is alpha plus beta 2. Secondly, now we can also show the alpha remaining the constant and there is change in the slope. Now in order to show the change in slope, we will assign dummy variable to y in case of y, and alpha will remain the same. So d is equal to 1 when it is boom period and 0 when it is depression. So when there is boom, then d is equal to 0. Put d is equal to 0, then consumption function is equal to alpha plus beta 1 plus beta 2, yt common, and slope now becomes beta 1 plus beta 2. And in case of depression, d is equal to 0, your slope will remain same, beta 1. So in case of boom, slope has changed from beta 1 to beta 1 plus beta 2. In the form of diagram, clearly you can see that earlier the equation was, the regression line was this, and now the regression line is this, where intercept is same, there is no change in intercept, but slope has increased to beta 1 plus beta 2. So in this way you can show the change in slope. Next, we can also show the change in both slope as well as change in intercept. Now in this case, we'll assign dummy variable to income variable and without income variable. So d1 is assigned to both. So when d1 is equal to 1 when there is boom, and d1 is equal to 0 when there is depression. When d1 is equal to 1, put d is equal to 1, so you will get alpha plus beta 3, and then beta 1 plus beta 2 yt common. So slope has changed to beta 1 plus beta 2 and intercept has changed to alpha plus beta 3. So in diagram you can clearly see that earlier slope was this and now slope is beta 1 plus beta 2, and there is also change in the intercept. So in the next application, we can also check the stability of regression. So what do you mean by actually stability? So stability means if the intercept and slope are constant over a period of time. So that is, if there is no significant change in the values of its intercept and its slope, then we can say that a regression is stable. Specifically, we may be interested in finding out whether there is any change in consumption function after economic reforms which were introduced in 1991. Say we have a time series, data from 1970 to 2019, and we all know the reforms are introduced in 1991. So in place of dividing data into two parts, we'll use a combined sample from 1970 to 2019, and we use dummy variables to see the effect of reforms. That is how the consumption function has changed after 1991. So for this we can define our model as follows. So Ct is equal to alpha plus beta 1 yt plus beta 2 d1 yt plus beta 3 d1. So here d1 is your dummy variable, and d1 will have one value if the observations are from 1991 to 1919 period, and if the observations are from 1970 to 1990, then your dummy variable will be equal to 0. So suppose d1 is equal to 1, that is, we are having a case of observation 1991 to 2019, then d will be equal to 1. So put the value of d is equal to 1, and now consumption function is alpha plus beta 3, alpha plus beta 3, and then beta 1 plus beta 2 into yt common. So slope is beta 1 plus beta 2 and intercept is alpha plus beta 3. Case 2, if d1 is equal to 0, so in this case put the value of d is equal to 0, and you will get a simple consumption function without any change in the intercept and slope. So in this way you can show that earlier your model was Ct is equal to alpha plus beta 1 yt plus yt. If the economic reforms do not have any significant effect on consumption function, then your beta 2 and beta 3 will be approximately equal to 0. Means this coefficient, this parameter beta 2 and beta 3 will be insignificant, and your model will be simple. Ct is equal to alpha plus beta 1 yt plus ut. But in case economic reforms have significant effect on the consumption, then beta 2 and beta 3 will be significant. Their values will be significant, and your model will be alpha plus beta 3 plus beta 1 plus beta 2. Here beta 3 and beta 2 are significant. So your consumption function has changed due to economic reforms. So in this way you can show that economic reforms has actually able to observe any shift in the consumption function or not. So what does it mean actually is, if the consumption after 1991 is significantly explained by income and economic reforms, then there will be shift in the consumption function. Otherwise the consumption function will remain the same. So in the next lecture we'll cover the other applications of the dummy variable. Thank you very much.